Okay, picking up on 3.3 derivatives of inverse functions. So we kind of went over some inverse trigonometry first before we got started into this. So once we did that, then now we're talking about the derivatives of inverse functions. And so what we're going to do is just go straight out with some of the rules here. So we could say that u is equal to 2x minus 1. So we're going to use some we're going to use some chain rule with this. So we got du dx is then, of course, equal to 2. So f prime of x then is equal to 3 times. So we have the constant 3 out front. 1 over the square root of 1 minus the quantity. And you could use, we'll use u squared for right now. And then times du dx. So there's your rule. Or u prime, so I usually use du dx. It's the same thing, just so you know that. If you look up here, I have u prime in the numerator. Either one makes no difference. Du dx or u prime. So we have this f prime then is equal to, we have f prime of x is equal to 3. Oh, and we have 3. And then we have times du dx or u prime. I'm going to put it in the numerator. And this is going to be over the square root of 1 minus, then we have 2x minus 1 squared, and that's all under the root. So we end up with 6. So we have f prime of x is equal to 6 over the square root of 1 minus 2x minus 1 squared. And there you have it. There it is. Okay. Now for the next one, we have arc cosine. Arc cosine is easy to remember because it's just the opposite of arc sine. So we have g prime of x we're looking for, and we have u is equal to x over 3. Now sometimes people use the quotient rule with x over 3, but it's actually quite easily done because it's a linear x. So du dx in that case is really just going to be 1/3. So we have this is equal to 5 times 1 over, we're going to make that 1 negative in the numerator, negative the square root of 1 minus u squared times du dx. So we got g prime of x is equal to negative, we're going to put the negative out front, 5 over square root of 1 minus, and I'm going to put the u in, u is x over 3. And square that, and then multiply times du dx, which is 1/3. So sometimes what we'll do is we'll just say g prime of x then is equal to negative, and I'll put it 5 in the numerator, and I'll take this and I'll put a 3 down in front of the radical just because it's a little bit easier to, I don't know. And this is not as, you just square the x over 3 and there you have it. Okay, next one. So there's number 6, number 7. With number, oh, and we could manipulate, actually, I should say this, that, and I'll leave it up to you to look at this and how I got to this stage. It would be the square, 5 over the square root negative, let me take that negative out there, negative 5 over the square root of 9 minus x squared. And I'll leave it to you, the listener, to try to figure out how I get to this stage. And it actually is kind of neat like that, all tied up. So in this next one, we've got u is equal to square root of x, and then du dx is equal to 1 over 2 square roots of x. Like so. So then if I have f prime of x, then I have arctan. So I'm going to write it like this, u prime over 1 plus u squared. So in this case, u is square root, so we have f prime of x. I'm just going to plug that in, and then I have 1 over 2 square roots of x in the numerator for du dx, and then that's over 1 plus, and then I have the square root of x squared here. So then I end up with f prime of x, and this 2x here is going to slip down into the denominator. So it'll be 1 over 2 square roots of x, and then it'll be times the quantity 1 plus x. And that's actually a fairly neat form. Okay. Okay, and then I have one more that I'm going to do, and that's on the product rule. Okay, if I have the product rule, so I have to use first or second plus second or first with this. So I have h prime is equal to first x to the fourth times the derivative with respect to x of arc cotangent. Remember, all the derivatives of the arc or the cos are negative. So I'll have to think about that when I get to that point. So then I have first or second plus second. The second is arc cotangent x times the derivative with respect to x of x to the fourth, just to be parallel with my process. One of the things that I find to be fairly important is sometimes you jump around and you do things out of order and you try to bring them together, and that's where errors occur. So we have x to the fourth, and then that's going to be times, that's going to be negative 1 over 1 plus x squared. Okay, so we have that in there. Plus we have arc cotangent. We're not doing anything with that, but we're taking the derivative of x to the fourth. So I'm going to be careful with that. I don't want to mix the x and the 4x cubed together. So the only two parts that you have to do any derivatives on are here. The only calculus that is here, and then you just combine your expressions in the end. So in that, I would combine the first one. That's negative then. And then I have the arctangent. So I would probably write this as h prime of x is then equal to 4x cubed arc cotangent x, and then minus, I would put in the x to the fourth upstairs. Remember, that's minus because of the negative 1 over 1 plus x squared, and then over 1 plus x squared. And there is your derivative. Okay, now we're just kind of doing the mechanics of the derivatives. We're not really talking about what they mean or how they are as a rate, okay, just getting through them. There's a couple more that I have to do, example 9, and well, a couple, but I wanted to send this video, and that'll get you started on completing these, okay? All right, I will see you when I see you.